Okay, this is part 2 of our imaginary numbers. We just got done with multiplying this previous example. Now I want to multiply these and see how we could understand how we can multiply these numbers. Now, the square root of -8, we talked about the square root of 8 in our section 1.3 video with just square roots. Right now, I'm just going to break it up as -8. Now, this -648, I'm kind of looking for an 8 here of how I can do that. So 648 divided by 8 is 81. So I'm going to write this as -8 times 81. And I notice that 81 is a perfect square, right? That's 9 squared. So I can take that out. And so 9 -8 times -8. Now, I can start breaking this up, and this is 9 times root 8i, root 8i. I can break it up that way. And square root of 8 times the square root of 8 is just 8. The square root of anything times itself is just itself. And then we have that I squared. 9 times 8 is 72, so I have -72 as my final answer, okay? And so that's how I would break these up. You can use the first one as kind of a clue of what you should do for the second one. Just kind of look for that same term. Yeah, and that should help. You have to be a little careful about pulling out the I for the negative sign here, but that should be fine. And I want to call myself out. In section 1.3 in our square root videos, I talked about the product rule. Square root of a times square root of b is equivalent to the square root of ab, but I just showed you that the square root of -8 times the square root of -8 is not positive 72, but it's actually -72. So does that mean that the product rule is wrong? Does that mean that I'm lying now? Did I lie then or did I lie now? And essentially, what I'm trying to get at is that the product rule is only going to work with real numbers. And with complex numbers, especially like the square root of -8, which is an imaginary number, we need to be a little bit more careful about our definitions. With real numbers, we don't have to worry as much, and that's what we're more familiar with. But we have to watch out for that. So I wanted to bring that up, that there's a difference of answer there, and in the previous section we'd get one answer, and now we're getting a different answer, and how those are working. The product rule is only referring to real numbers. Okay. Let's talk about dividing complex numbers and how we might do that. So I have the square root of -5, square root of -6, and the square root of -4. So one way I can do this is I can take I can just take the -1 out and just put my i's. So square root 6i, square root 4, and we know that. Actually, we know that that's just 2, so I'm going to write that way. Okay, so you can either excuse me, you can either multiply these i's in the denominator to get a -1, or you can cancel one out. I find it a lot easier if I multiply the ones in the bottom, because I'll just get simply a negative number. So -2 root 6, and the I went away because they multiplied and they turned into a negative number. And so I can write the final answer as -1/2 and then square root 5/6. And see, I am using the quotient rule there. And then there's just an I here. So that is a pure imaginary number where a equals 0 and b equals -1/2 root 5/6. Okay? So that's kind of a weird number. It's not, the most common numbers in math problems, but that's how we can do it. All right, for this next example, we have 4 minus 2i over 8i, and really I want to get this into a plus bi format, and I need to get the I out of that denominator. And one way I can do that is that I can multiply both top and bottom by I. I divided by I is still 1. And so I can multiply top and bottom by the I, and this will give me the result that I require. So I times I is -1. So 8i times I is -8. And then I distributed this I here. So I get 4i minus 2i squared. And that's going to become positive 2 plus 4i over 8. And now I can do something we learned a long time ago, which is called splitting the denominator. So I have 2 eighths, 4 eighths I, and 2 over 8 is 1/4, and 4 over 8 is 1/2 I. And so this would be the final answer, and this is A equals 1/4 and B equals 1/2. Okay? Yeah, so there's some fraction stuff going on. There's some complex numbers going on there. But the technique was to multiply I times I, which is really just equal to 1. But it was able to get rid of that I in the denominator, and so we were able to break up the denominator. All right, I think there's enough time for at least one more example. So I'm going to talk about 1 plus square root of -4 over -3 plus square root of -16. Now, this denominator is broken up by addition. And because it's broken up by addition, I can't just simply multiply by I to fix it. I'm going to write these out. We know that the square root of -4 should be just 2i now. -3 plus 4i. Now, I can't just multiply by I top and bottom because it won't get rid of the problem. I'll just attach an I to the 1 and -3, so that doesn't help. What I need to use is our conjugates. We used conjugates before to get rid of the cross terms in our factoring, so I need to do that again. So -3 minus 4i, -3 minus 4i. These are called complex conjugates, and they have the opposite sign in the middle, and this will get rid of all the cross terms that we need to get rid of. Okay, let's do it. So on the top, we're going to have -3, -4i, and then -6i minus 8i squared, if I distributed that right. And then the bottom, we have +9 plus 12i minus 12i minus 16i squared. I think I did that right. No, I didn't. I should write 12 there. Okay, what do we have in the numerator there? We have -3, 4i. This is going to become a +8. So +8 minus 3 is 5. -4 minus 6 is -10i. And these 12s cancel. So we get 9 plus 16, 5 minus 10i over, and that's going to be 25. And then now I can finally break up that denominator, and so it's 5 25ths minus 10 25ths I. And now I can reduce. That would be 1/5 minus 2 fifths I. And so A equals 1/5. Whoops, and I wrote 1/2. 1/5. And B equals -2/5. Okay. Well, that should be enough for this video, but a lot of steps there, but it's all about doing the complex conjugate. That's what we're trying to do. I use the complex conjugate. Okay? We use the complex conjugate, which is just the opposite sign in the middle there. And that's how I got that. All right, it's enough for this video. We'll do a couple more examples in the next video.